So today we're gonna be back with our Viper session, and we're gonna try today to create an ERC20 token. I'm here with my friend FPS, and we're gonna try to do that once again. My knowledge of Viper is very basic. We did this simple storage contract the other day. We managed to verify it and everything. So today we're gonna try to come with a ERC20 and do a little bit of research regarding what are the possible caveats that you get, if you have something like Open Zeppelin and everything. So yeah, that's it. Let's start. So once again, I'll just do what I do in my day to day when I need to research something. So I'll just go on Google. And now that I know a little bit of Viper, I even want to open the other project. Let me see if I can find this easily here. Yeah, I have it here. We just open it, and so this was pretty much, and if we look at the folder, projects, one, this is pretty much the only thing I have in there. So I'll just try to do you know, the most basic possible thing, which is how to create an ERC20 with Viper. Using Google is probably one of the most important, skills of a developer. Google is your best friend, especially Stack Overflow. It's really good to know things, over the basic and everything, but sometimes we just need to solve the problem. So learn how to use Google is very important. What I'm gonna try to do here is get everything that was from the last year, just so I don't get nothing that is too outdated. And we do have a few articles here, but I wanna see. So we have some Viper walkthroughs here. One is for a ERC, and I would like to understand what is the testing. I think how do we do testing with Viper? I'm just gonna take a look at a few things here. Okay, so I have this Viper ERC21 contract walkthrough. Operator, token ID, data bytes, some events. Okay, so here is already something that we can use. I'm just gonna try to see if I can find, maybe I'll need to remove this filter, okay. And then I have this ERC20.py, but I also know, I also wanna do something like, and I want to search for Viper ERC20 plus tests, I guess. So I'm trying to find repositories that have, Viper contracts. Once again, always look at the date, so you don't want to open something from 18. So let's take a good look here. ERC20 Viper versus Solidity. Very interesting. We have both the contracts here, right? And I want to take a look at the tests. Simple test. So it looks like I can just use Hardhat to test Viper, which is nice. So today we're going to try to dive into a little bit of testing. So try to do a little bit of testing of the token and try to do, try to recode it. I'll disable for Viper Copilot, just so we can actually look at the code and just rewrite it. I think is an important process, and try to understand what's happening. Of course, we have a token here with 11 contributors, and would like to know if there's any standard ERC20 Vyper. And I also want to know if Open Zeppelin, so two things I want to know. There's anything from Open Zeppelin regarding Vyper. Reported some of Open Zeppelin tests with minimal change. Okay. Interesting. So here we actually have a, how old is this? 5 years ago. Well, that kind of kills me a little bit. Not gonna look at it. Let's go back and let's take a look at this. Let's try to replicate and do some testing, and let's try to write, to understand and write this contract. So let's try to explain it as you write it. Okay. So I'm just gonna put the code here to the side. And as we learned from the last session, the name of the contract, the name of the file. Okay. Very interesting. We start to, I wonder if this from Vyper.interfaces interfaces import ERC20. I wonder if that works. Let me save it. Do I need to stop plugging here for Vyper? Probably. So I'm just gonna do that now. Add the Vyper plugin. I don't know if that's already installed. Semicolon statement. Yeah, I don't need the semicolon. Okay. Let's. Okay, looks like we have something here. I do not have autocomplete though. I wonder if I need to do something to make that work. So from Vyper interfaces import ERC20 detailed. Okay, so the idea here, I think we are importing both these libraries, and let's talk a little bit about them. I know everybody here probably already know what they are, but I want to talk a little bit about ERC20 detailed. Those are pretty much EIPs. So we have the standard, the standard spec for tokens, and we have a little bit of deviations on the kind of token, right? So let's see what ERC20 detail does, because from my head I don't really know, but it should be easy for us to understand that. So this is, I wanted something a little bit on the newer side. But I guess we can just look at the description for the implementation anyway. So let's see. Okay, so here's a fun fact, right? Name, symbol, and decimals are not mandatory fields in the ERC20 implementation. These can actually lead to a few problems, and it's an important factor to consider while doing some sort of audits. So let's go, and I see something new here, which is implements. I think we are dealing with a little bit of the Python syntax here, because we probably imported both objects, or classes, let's call them classes, or contracts also, both contracts, and now we need to inject them into the class itself, in the contract itself. So I wonder if that's what's happening here. Then we do a first event declaration. This is also nice because it gets you to see what is a token? It's just a specification, just, so event transfer. I guess we already know that this will be used to pretty much log out, not even log, but really create event during our transfers that you can track that off chain. You know that. So this is using something called a Bloom filter. If you guys want to dive into that nerdy stuff. U 56. So here we have a classical event, structure, and something also nice about Vyper is, you get this easy and cool syntax, really goes with Solidity. Like if you come from Solidity, you can write this. Maybe after writing 2 or 3 contracts, you can already do it. And then if you have a stack of people working with Python, seems to me like. Hey, how's it going? So Ryan, good? Right now we're going over Vyper implementations of the ERC20 token. We just started about 10 minutes. And the idea is to try to understand what is the ERC20 implementation, so which is a very basic, but so often we forget about the basics. And trying to see what that implementation looks like in Vyper compared to what would be in Solidity. We're following a code that we found here. And after doing that, I'm going to look around a little bit on GitHub to see if I can find other examples of different things. And we may even dive into maybe making an NFT or something more adventurous after we do. I also want to do a little bit of testing here. So I want to do testing for, maybe some events, some approval, and a transfer, nothing much complicated, just so we can also understand what is the test flow of using Vyper. Cool? Let's keep on. So here I have state variables. First thing, name, setting that as string, 32, okay, symbol, and these are all aspects from ERC20 detail, okay, decimals. There are also some important things, like when you do transfers with USDT, you don't get the result if the transfer, I think always returns true or something like that. So you need to be careful with that. Because someone can create a poisoned token and screw your protocol. Okay, let's go for the balance. The balance hash map address 256. Here's the allowance. Here's the total supply. And we have a meter. So these are all state variables. I'm just copying everything. But here, the hash map is from, so we can see that the key is for nested mappings. So something interesting we can see here is a nested case of mappings. So if we
I
take,
can't see your screen well.
oh yeah, let me share my screen. So here we can see we have nested mapping. So based on address and probably address and allowance. So very interesting. Then we have a public total supply. So here will be public 156, and we're gonna have a minter, which is just an address. Okay, awesome. Now, so what we have of the ERC20 so far? We kind of have two abstract interfaces, or two interfaces that we're using to make a standard, like have a standard to follow in the code, so we don't, you know, come up with a token out of our hats. There is actually a very good article about that called, I think, Crazy ERC20s or something. I'm gonna link that in the video. And then we have two events, one for transfer, counting with the sender, receiver, and value, and one for the approval. Once again, the owner, the spender, and the value. And important, again, to talk a little bit of how the fact of those being indexed makes it possible for us to go and search for this information off chain. So it's useful, you know. And we have some state variables, one for the name, one for the symbol, one for the decimals, one for the balance, one for how much you can spend, or meaning the allowance, one for the total supply, and the minter. One question that I have here though is regarding the decimals. So I'm seeing you in 8. Which I think can also be used for decimals in Solidity, because we're just using two numbers mostly. So yeah, interesting choice. Let's take a look at the constructor and re-implement it. So when we see the constructor, we see that we have a name, symbol, and decimals function. Interesting, you know, it's the same format that usually you're gonna have that with OpenZeppelin. So you have the name, the symbol, decimals, and the supply. Here you can do a initial supply, okay? So after that, interesting, this convert. So it's a different way of casting data basically, right? Here you would be using like the denomination of the type, and how now we have a function plus the type to make the conversion. So this is something that is a little bit different. Then we set the balance of the owner, total supply, the minter, and we immediately log. Very interesting. Let's re-implement that, and let's go through. Development is not magic. Security is not magic. All these things are very possible, easier than you think. So let's go. First thing, we do a name. Then we do a symbol. Then we do a decimals. I'm just gonna put this. And what else? We do the supply. The supply here is a uint. So supply would be a uint 256, and the decimals would be a uint 8, and both the symbol and the name are strings. Always be consistent with code, so don't leave like one places with comma, other places without comma, or you leave it with a space, or no space at all. You can see what they adopted here in the code was to put a space after parameters. So let's add that. Remember, always be consistent when writing code. Okay, and then the first operation that we have is to calculate the initial supply. Okay, and this is important because we're gonna see that all around in pools, tokens. Whenever they got deployed, they need to calculate some collateral and stuff. So it's important to understand what is happening behind there. And there is a very special research that you can do on high order bits on Solidity and how casting can be effectively dangerous if you're not considering what can happen in there. So yeah, let's go back, and here let's go for init supply equals u156. Not really equal. We're gonna use this, and then we're gonna say that we're gonna use the supply times and exponentiate by the decimals, could be 18 in this case, for a, but they're gonna convert the decimals to 100 because they are coming from uint8 to this. So yeah, I think this helps you. You just can use just true numbers, and then we do the conversion. You don't have to send all the decimals. Let's keep on. Self.name equals name. Just gonna do this, and I'm just gonna do these. Okay. And then we're gonna say symbol decimals one frame. And we're gonna say supply. So decimal, symbol, name, supply. We have here the basics. We just need maybe the balance. Now let's take a look. So let's balance of who? Message dot sender cells balance of. So this is an array, and we're gonna say, or maybe a mapping. Actually, let me check. It's a mapping, not an array. Balance of message dot sender. It's equal the init supply, and then we're gonna do a self dot meter equals message. I wonder if I can do some optimization just by not using the sender again, but I believe the sender just replaced at the compiler time with the address. So just do message dot sender. Are you guys listening to me?
Sure, yeah.
Okay. So we do need to add the total supply. Which is the same, once again they need supply. And then we're gonna do a log here. So I'm gonna log the transfer. Just gonna check something, everything alright? Yeah, everything alright, okay. So we're gonna log the event that we created here, okay, transferred, saying that coming from address 0, because this is being minted, right, to message.sender, we are sending the initial supply, okay. I also like being consistent regarding variable names, so I'll never do initial supply like they did here. I will do init supply like this because they're using camel case all around, so I don't see why would you use a different kind of notation. But for the exercise, I'm gonna keep it like that, okay? Awesome, so we have our constructor. Technically, now we need to implement the transfer functions. The transfer from function, the approve function, the min function, the burn function, and the burn from function. And there's even functions here to burn like the sender supply and stuff. I'm gonna start doing the fun stuff. I don't even wanna do burns, but we're gonna do so just for the exercise. But let's do transfer first. And we transfer, the parameters are once again 2, which is an address, right? Then we have value, which is also not an address but a int, sorry. So what we do in a transfer, so we load the balance of the sender, we load it, and we decrease the value of the sender by the value of the transfer. So as you see in the second parameter here is value, and now we are decreasing that from the balance of the sender. And we are now adding that to the balance of whoever is the address of the person that is receiving that value. Minus equals, and equals like that means that whatever value you have in here minus this value, plus equals means whatever value you have in here plus value. Otherwise you needed to do something like, you know, balance is equal this plus this, you know. It would work the same, but maybe it's not so efficient. Let's go back. And then we do a log transfer message.sender.
Does Vyper check for overflows and underflows?
What?
Does Vyper check for overflows and underflows?
Yeah, I wonder if that's happening, you know. So there's actually a very important notation here. Vyper does not allows underflows. So subtraction would revert. So Vyper kind of takes care of a few things: bounded memory, reentrancies, and underflows. Overflows, I think in that case we're implementing a function just like a little bit of the safe transfers from OpenZeppelin, because they also revert in the case of overflows. So yeah, that's nice. You know, it's a nice observation, FPS. Thanks. Let me go back. So after we added the balance during the transfer, we wanna log it. We wanna log it. You know, we wanna know, let the people that this transfer happened. You know, so we're gonna say true and value. There was a funny case where someone was making a lot of money from MEV bots just by manipulating this thing. So he was actually sending less value, but the event itself would say that the value was full. So bots would buy like extremely expensive tokens and would never manage to sell them. Very smart too. Let's do one thing that we forgot to do here is the visibility of the function. We need to see the external, and I wonder if we need any visibility for the constructor. We do need to say that the constructor is also external. Okay. Now let's keep going and let's implement the transfer from function. I'll just copy the code for transfer, and I'll do transfer from, and I'll add the address from and to here. So let's put these guys here, okay? So we have address from, address to, and the value. And one interesting thing about the transfer from and the transfer function is both of them return a boolean. And although I'm not, although I that I see here, all that I see here is a return true. I imagine that any reverts will result in a false automatically being returned. So this will be the same for the function here. So I'll just copy this. And what we change here mostly is we do a, instead of doing a message sender, now we're going to do it based on these addresses. One important thing to consider is that we need to have allowance to do this. So if we understand the concept of the what's happening here, we are pretty much setting up the, I don't see a check for allowance here though. Isn't this code wrong? Oh, I know why. So you see, because of one of the characteristics of Viper not underflowing, we don't need to make the check for the allowance, because look, I can even do this, okay? So I can run this part of the code, but there's no allowance, meaning that the self allowance from to me will be 0, and automatically this will be, you know, reverted. So that's actually very interesting, an interesting point. FPS, you there?
Yeah.
Cool.
I'm here.
Okay.
Hello?
Hey, no, okay. Just checking because I don't know if
I'm
I'm
here.
okay. So now we're gonna set the allowance check. So this is really like the whole allowance check, you know, like so from, and then I'll do message.sender, whatever is the value minus what was sent. So this is our transfer from function. We can almost do an exchange now. We just need the approve. So let's keep on going. I wonder if transfer from, you can see the transfer from uses the same event, which is okay. I mean, it's transferred, right? It's a transfer. Anyway, maybe you could have an enum for the transfer type, but that will break the AIP specification, so there's no point in doing that. So let's go for the next function, which is the approval. And once again, this may seem very basic, this may seem very, but you know, that's what this research is about. Is, you know, if tomorrow someone comes, hey, I need to pump up a Viper contract, we kind of know how to do it, you know. It's not about coming here and delivering the best, most amazing. Actually, it's about making mistakes, okay? So let's go. So we have the approval function. What is the, how the approval function works? It takes two things. It takes the spender, meaning that what is the address that can interact with these tokens on my wallet, and the value, how much does this address can take, okay? And what we need to do here is set like the allowance mapping. So here we're gonna set that. Who's sending? So we have a position here in the mapping for who's sending the request, meaning that who's saying, hey, I'm approving this, to the spender. So here we have a spender saying that, look, the value was authorized by this spender. Then we do a log. Okay, so now that we have Hardhat, let's go for npm or npx hardhat init, I think. Create a TypeScript, JavaScript, I don't know how I'm feeling today. Type chain, I'm gonna go with JavaScript, okay, just to make it a little bit easier for us. Yes, I wanna add the ignore. No, I don't wanna send no data. Okay, so we have Hardhat. Now I'm gonna enable our friend Copilot again because I want help with the tests, you know. I'm gonna move these contracts, two contracts here, okay. And I wonder if I can just like do a hardhat compile and that will compile, you know, like so if I do npx hardhat compile, if that's not gonna happen, you know. Let me see if I can do that. Once again, I'm always gonna be using Google. Once again, Google is your best, you know, best tool. So I'm gonna say deploy Vyper contract, deploy Vyper contract with hardhat. Let's see if that's possible. So we have a plugin for that called Hardhat-Vyper. And that's interesting because it will allow us to see how to use, you know, plugins and everything. So let's add this with Hardhat. So let's add this. Okay. Just gonna copy it here and paste it. Boom. We have a log file, my contract. Let's focus on this one. So now that I have the plugin, I'm gonna go for requiring it on my configuration and importing it on my config.ts. In the case I'm using the JS, so I can just require it here. That's what I'm gonna do. So yeah, let's go and let's put this here. So now technically we should be Vyper compatible. So I'll just run the same command and see if anything changes. Aha! Seems like we found something new. So apparently we're going through the compilation of this contract and he's going for one thing to see here. I never specified the version, and now we're using a more advanced compiler, so we're not using the 0.2.6 that we were using before. And I want to do, before even proceeding with writing tests and doing all these things, I want to do a full deployment process through Hardhat so we can learn that. And we're going to deploy this contract, deploy and verify that through Goerli testnet. And one thing I want to call you guys attention to is a plugin Hardhat. If I'm not mistaken, it's called Verify. This guy, because it allows us to verify contracts straight from Hardhat. So I'm just going to use that, so it's a little bit easier. Okay. And we also have to support the net to set up the network. That should be easy also too. I'm just gonna ask Copilot to give me that. So I'm just gonna say, hey, I think it's gotta be inside this thing here, but I'm just gonna say, hey, setup Goerli testnet networks Goerli. You have Marfura. Do we need a chain ID? I don't think so, right? We don't need a chain ID. Okay, and I need the account, right? Okay, just gonna, regarding the account, I'm gonna check that in a second. But there's no secret, we simply add the network block here in the object, and we set in the network that we're gonna use. And we're gonna pass in our Infura key and our private key to make everything happen. We also need to set up our Etherscan key to do that. So we also have that part. So let's start with getting the Infura key, and from the Infura key we do the other things. Okay. So first thing I'm gonna do is just open Infura, you know, infura.io if I'm not mistaken. Then let's click on login, probably, because I should have some IP here or something going on. Let me see if I can log in or not. Which account I'm actually using. Okay, so we're gonna create a new key here. And it's gonna be for a Web3 API. The name of the project will be a Vyper contract. Let's create it here. Invalid section. Please log in again. Well, that's interesting, I guess. So we're gonna create a new project, and we're gonna get an endpoint. This time we're gonna go for Ethereum, and we're gonna choose Goerli. Just gonna copy these, paste it here. And I also want to add, I don't know if I don't know if this is here, but I think it's here. Add private key for wallet. And I think it's an account, not inside networks, probably just here. I want to look at some Hardhat implementation. I think we have one, a good one on Sushi GitHub. So Sushi GitHub, because they have to run on all these networks, and if I'm not mistaken, their front end has Hardhat. Their contracts are all made with Hardhat. Sushi Swap and repositories. Sushi Swap. Are those the contracts, or is this the front end? Interface assets, staking contract, Sushi Swap, Bento Hardhat framework. Let's see the Bento box just to see something. No. Let me take a look here. Maybe this is not only the front end. Yeah, this is the front end. I'm trying to find the contracts. Okay, so here we have an example of a Hardhat file for different networks. What I'm trying to see here is I want the private key that will be deploying this. And I want, okay, we have the gas reporter, named accounts, and I'm just gonna copy this section here because I'm gonna need that for the Etherscan API. Okay, awesome. So here I have, Etherscan, carry the API key, and I'm gonna right now load into Etherscan and get a API key. Probably gonna go for Goerli Etherscan. So Goerli Etherscan. There we go. And then we're gonna have to probably log in or something. So there's a login button somewhere here, probably. API documentation. I wonder if I can verify a Vyper contract using that, or I'll have to verify it myself. Maybe I should just focus on deploying before verifying, right? I think that will be a little bit faster. Let's go for the deployment. So I'm gonna go on Google. I just need to see something really simple here, how to set a private key on Hardhat. And how to set private key hardhat.config.js.
Yeah, so I think right below the network I can put that. It's one of the options I have is to go with this. Then okay, I'm just gonna load the private key that I had from the wallet that we created the other day to test this. I think it was in Chrome or something. This is becoming a Viper hard hat and everything together lesson. That's okay. Let's just wait a little bit so MetaMask opens up. Okay. Luckily I remember the password. Close this, got it. We have got a little bit of Goerli if here. I'm gonna get this private key and don't even try because this is just the burner. And spend view. Actually, it shouldn't even be came here, that's okay. Let's just wait a little bit. So you need to click on the three dots, account details, this private key. Never, never, never share your private key with someone else, okay? I'm just doing this for test purposes. So if I'm not mistaken, all we need to do is copy this here, but I think I need to add this 0x. I'm not totally sure though. I'm not totally sure though. I'm gonna set it as a string. And okay, now we need to come up with the script to build and deploy this. So usually on Hardhat, you're gonna do that on a deployment script, like we have one here, okay. We're gonna change it a little bit because, well, the contract we're trying to deploy is another contract and takes different parameters, the parameters we're trying to deploy. So we're gonna try to work those. So the first parameter that we have is the amount. Let's take a good look at the token contract because I think that will give us a better notion of how do we need to deal with the deployment script. So split down so we can have both views, and I'm going to look at the constructor because I want to see what do I need to pass in for the informations here. So what I'm going to do is I'm going to pass in const name. The name is, I'm going to comment down all this code. So this code is not really necessary. We're just going to look at it to see how Hardhat deal with things before to use it as an example, okay? So first thing I'm going to test to deploy this is the name of this, okay? So I can say 42069, okay? This is the name. And then I have a symbol. And for the symbol, I'm gonna call it FTS, okay? And then for the decimal, I'm gonna put in 18 because I'm using Uint 8. But I'm not sure if that's how that's gonna work, but we're gonna see for sure. And my supply, instead of using these, I'm just gonna parse. So I'm just gonna say, hey, a chair, ethers, parse ether, and we're gonna say that we're gonna have 1,000 tokens. Good. Okay, and then so we have all the information we need to start our constructor. So how do we proceed now that we set up the name, the symbol, the decimals, and the initial supply? we're gonna deploy it. So to deploy things with Hardhat, you usually get the contract factory. So I would say, hey, const token equals await Hardhat environment, load ethers, and load the function get contract factory that will now look for a contract artifact, and based on the name of the contract, so because we named our 42069, this should be the name of the contract. And let's just see if that's completely broken at this point or if we have something. So let's just do console.log hey hey, and I do not remember how to run scripts on Hardhat. If I'm not mistaken, is npx hardhat run deploy. That worked? Oh, there's an error. Yeah, because it's looking at my configuration files expecting this to be set up. I'm just gonna comment it for now. And let's see how that works. I think with Hardhat scripts, I just need to say the name of the script. Maybe I need to go in the folder for scripts deploy. So right at the batch, I have an error. And I want to look at the artifacts here because I want to see something. I want to see. So I want to see Hardhat-Vyper deployment. And I'm trying to find I'm just gonna put these, gonna copy the error, I'm gonna go on Google. Remember, go on Google. Google is your friend. You're a developer, Google is your best buddy. You know, I'm gonna say Google, and I'm gonna say Viper, and I'm gonna paste this. And did I forgot something in the contract maybe? Let us take a look in the smart contract to see if I forgot something. Maybe I have something like Viper. If that works, that would be crazy. see if I can find some documentation on the plugin. Guys, remember, development, resilience, okay? Resilience. And there's a small trick I'm gonna show you guys. You can go on gist.github and you can search for pieces of code. Yeah, so apparently this is not the best search I could do. Not a lot of things going on. I want to see, you know, a little bit of the documentation of these. Okay, so we fixed a few problems. Let's see if that helps us compile and try to deploy this. Okay. That's much better, isn't it? Because now, now we know that we need to pass in all the cool information, like, so this is the name, symbol, then we have the decimals, right? And the supply, which I need to, decimals are 18, and the supply is hra.ethers.parse utils probably parse ether, and let's say 1000 ether per supply. Okay, now we have all the information to deploy our token, and let's try it again. Oh, baby! We did it, man! Can you believe this? Okay, now that we have our r423 token, we want to verify it. And to verify it, we need to set up the Vyper, not Vyper, but the API, Etherscan API key. I think the same API key works for all the networks, though I'm not sure, so I'm just gonna go for Goerli here. Goerli, and I wanna go for the API. For the API stuff. I don't know if I need to. Yeah, I think I can just use Etherscan, my Etherscan key to do that. I'm gonna do. Don't. You can try to copy. I'm just gonna revoke it as soon as this thing is over. This video is over. So don't do that. Now remembering, like, I remember that getting this password from Etherscan. This is always like. Travel. Okay, let me. So we just logged into Etherscan, and I'm gonna get an API key here. It's gonna ask me to log in again because you know that's what Etherscan does. And you can forget to click here too, like this. Why would the UI remind you of that? Save nothing. Let's just go for API keys, and I want to go to copy these API keys. Okay. So let's just copy these. Then let's paste it in here. And now, if everything works, we should be able to verify this contract without too much hassle. So let's try to do this. I think this is Hardhat-Vyper. How do I run this command? Oh, I need to pass in the URL for it preferred. One second. There's something in the code I need to see. Where's my configuration file? You need to pass in the URL. Network etherscan URL. Okay, network etherscan URL equals. Do I need to put Goerli? I think I can use this for Goerli too, right or no? Goerli etherscan. So maybe this is the link. Nice. Okay. Now I need to provide an address to verify, and Hardhat makes it easy because you just need to pass in the address you just created. So I'm just gonna copy this address here. Now we just deployed, and I'm gonna try through. Let's see. Okay, apparently I cannot verify a contract on here. Okay, this is a little bit sad.
Maybe you could try. It says you're trying to verify the contract.
I mean, I can verify it there. I'm trying to verify with the plugin, and it's saying that the network is not yeah, not valid. I don't know if I can just to verify. I'm gonna need to verify it manually. Shouldn't be the case, you know. So let's go for it. There's no problem. Let's go for it. Let me copy the address. I paste it here. Vyper. Compiler is 30031. There's no license. I'm just gonna copy there's a tricky part here, which is setting up all the parameters. So I'm just gonna copy these, paste here, and I need to pass in the ABI encoded parameters. And let me see how I do that. I didn't load the parameters for me, right? Shouldn't need to do that. But let me see how can I. One way I can do that is looking at my wallet. So if I look at my wallet and see the deployment transaction, but I haven't verified yet, I won't be able to tell it. Can I just put the... One second.
Are you trying to encode the constructor construct arguments.
Yeah.
I think you should check the. Let's see the place you deploy the contract from. Let's try to encode it from there.
Okay.
Maybe deployment file.
Let's go for. I think Chrome has my MetaMask, so 1 second.
No, not the. I mean the deploy.js file.
Ah, okay.
Or config, yeah.
You can just
Yeah.
include these, right?
So it's the yeah.
Let me copy
Can start
these.
with encoding.
No, 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 no. I want to ABI encode constructor params. Aha, I think that works, right? So here's what you work with Copilot really. Let me see, I'm gonna see if we're gonna get the encoded parameters for yeah, in the ABI encode. Let me see how this function works. I Let me see this. Let's go for ChatGPT, and I want to say that I want to encode how to encode this using so I can verify. And you know, that's pretty much what most of the development routine will be now on, knowing how to use these tools and you know how to make the most out of it. Awesome. So there we got the information. Let's just replace this line with this, and let's try again. Peters. Resilience. It's the most important aspect of any developer. Awesome. So this is what we got.
Yeah.
Let's just copy these. Let's go and Goerli verify. Let's paste it. Let's see if we have any sort of different setting here. No, and if we're lucky, if we know what we're doing, or kinda, cars, we should be able to verify. Now is the fearful, oh no. Is there a valid contract address? Oh, let me give you, man, I'm so retarded, you know. Look at what I'm making, the mistake I'm making. So first I'm gonna first I'm gonna comment this, okay? Actually, I can just, do I still have the other code here? Yeah, we just, the problem here is that I'm not selecting my network, man. How do I, how can I verify something if I'm not setting the proper network? So the first thing I need to deploy this to the right network, right? So to do that, I need to use the network thing. So I need to go deploy network Goerli. Otherwise, this ain't gonna work. Network Goerli. Now I don't really know if the verifier will work in those. Well, look, now we have an address.
Yeah.
And I'll try to see if the verifier works now, setting the network, which shouldn't be the case. And I also need to replace, that dreadful address. Let me just copy these, paste it here really fast, copy these, paste it here really fast. Just copy that, just paste it. We're trying to verify a contract in Goerli, but no API token was found for this network. Etherscan, API key Goerli. So okay, so I can just say, hey, Etherscan, and I can say API key, and then I can do an object. And I can just, I'm gonna need both these things, you bet.
You should have added Goerli in the API key object. No, like Goerli then API key.
This shouldn't be the case because this is unrelated to the RPC. This is a website, So I think this is just no, deploy it again. This shouldn't work because this is unrelated to the RPC. This is a front end. Let's just try verifying it. Just gonna copy these. Oh, it's not easy, man, when you're trying to do research, when you're learning from the ground, it's not easy. Start over. Now it's gonna work. So please. And now we're gonna load the encoded ABI automatically. Basically that we learn how to encode that if we need. Oh no, we didn't. Okay. This is not very good. Being hopeful, trying to, okay, invalid constructor arguments provided.
Maybe remove the white. I think there's a white space down there somewhere.
But it's not trimming that? You should have trimmed it. I'm not seeing the name though, you see? It's all zeros. What the fuck? So now we just found out there's a way to add support to Goerli on Hardhat. I'm gonna try to verify the contract that we deployed, because I'm having trouble to deploy it on Etherscan. Let's see. I need to let me see what's the problem here. A is not defined. Probably something wrong here. You can see there's an A here. Let's just remove it. And okay, there's an error. Hardhat expected value of string. URLs. Still looking to see if we can verify this contract, but looks like we're having a few problems with that. It is okay. Let's just try it one last time, and then if it doesn't work, I'll ask help for someone very special. Okay. Let's take a good look in the contract, try to verify it. Viper 3.1, just a second. And here's the source. Let's take a look. This is all the faithful part. Okay, I'm gonna stop for now, but I'm gonna come back with the solution in the next video.